All right, hey guys, we're going to continue on with 2.1. I'm going to give you guys some examples. These are directly from the book. So we have example 1. So we're finding the slope of f of x equals 2x minus 3 at this point, the point 2, 1. So remember, the derivative gives the slope of a line's tangent to a curve. So in order to do this, the first thing that we're going to do is we're going to find the derivative of this function, and then we can plug in our x value of 2 later. So the first thing that we're going to do is remember what the definition of a derivative is. So f of x is, so it's f of x plus h minus f of x all over h as h goes to 0. So I can't even remember what the song goes, like f of x plus h minus, I can't remember what the song is. But this is the definition of a function. So we're going to, on the side here, I said, okay, well, what is f of x plus h? F of x plus h is, we're going to look at this function right here, and we're going to plug in, instead of an x, every time we see an x, we're going to plug in an x plus h. So that's what we do right here. We replace x with x plus h, and then we're going to simplify it. So now I'm going to plug that in here. So this right here, we plugged in right there. So these two are the same thing. And then this came from our function. So this is our function right here. So these two are the same thing. And we're going to simplify it. So we're going to simplify this sum. So we're going to distribute. Make sure that you distribute this negative. Don't forget to distribute that negative. So, and then after we do that, we're going to collect some like terms. So this 2x minus 2x, and we have a 3 minus a negative 3 plus 3. So these ones are going to cancel with one another. They're going to give you 0. And so you're going to be left with just 2h over h. We can simplify this. We can simplify, we can cancel out the h's, and we're just left with 2. So again, this means that the slope is 2 for all x values. It doesn't have an x there, so it's a 2 for all x values. And it makes a little bit more sense when we look at the graph. So the graph of our f of x function, 2x minus 3. So the graph of 2x minus 3 is going to look like this. But if we have, so the slope for at any point of this tangent curve is actually the slope of our line. This is the slope of a line. And we know from here, our slope is 2 everywhere. So this means that the slope of all of our tangent lines is going to be 2, including at 2, 1. So our slope is 2, and that's because it's a straight line. Straight line have a constant slope. So straight lines have a slope of, this one has a slope of 2 everywhere on the function. So that one, so there's that one. Kind of a weird one, a little bit. So it's a little bit weird. Okay, so we're going to look at example 2. So it says find the slope of a tangent line of the tangent lines to the graph of f of x equals x squared plus 1 at points. So we're looking at 2 points now. So we're not just looking at 1 point, we're looking at 2. And again, we're going to find the derivative. So remember, derivative gives the slope of the tangent lines. So derivatives give you slopes of tangent lines. So again, we're going to start off with our definition of the function the definition of a derivative. We're going to look at the definition of a derivative, which is f of x plus h minus f of x all over h as h goes to 0 is the formula for the derivative. I can't remember the rest of it is, but that's a song. So remember, I'm going to be giving you guys some extra credit for that. If you guys remember that, probably Friday. I'll let you guys know more about that tomorrow. So we're going to be plugging in f of x, f of h, x plus h. So here it is. I simplified it. We're going to plug in x plus h. Every time we see an x, I'm going to square it. So we squared it. I expanded it out over here. And this one, we're going to have x squared plus 2xh plus h squared plus 1. And I plugged that in right over here. So these two are plugged in. This one, f of x, again, comes from our function up here. I plugged it in right there. Don't forget to distribute your negative. So we distribute the negative. When you distribute the negative, now we can collect like terms. So these x squareds are going to cancel out. These 1s are going to cancel out. So all over h. And now we can factor out an h. So we're going to factor out an h from here. And h's cancel. So our h's cancel. We're left with the limit as x of 2x plus h. And remember, we're letting h go to 0. So we're going to use direct substitution. So direct substitution right over here. And so when we use direct substitution, it's 2x. This, so this is a general function for, and it'll show you the slopes of all tangent lines. So this is a general function that'll show you the slope of all tangent lines. But we're just looking for the slope of the tangent lines at 2 points. So 2 specific points. So here's our x value here. This is our x value here. We're going to plug it into our into the equation that we got for our derivative. So we're going to plug in 0 into this x and we get 0, and -1 into this x and we get -2. And if you kind of look at it on the graph, so I have the graph here of x squared plus h. If we look at 0, 1, the tangent looks like a horizontal line, which is x equals 0. So here's that horizontal line. At -1, 2, it looks like this negative, it looks like a negative slope. So this negative slope right here, which is at -2. So it kind of makes some sense. All right, that is it for this video. All right, thanks guys. Yeah.